Hey scholars! Welcome to Mathora. I'm Ms. B and you'll be learning with me. Today, we're solving equations from one step to multi-step. By the end of this lesson, you'll be able to solve one-step equations, solve multi-step equations, explain why each step works, and check your solution for accuracy. First, we're going to tap into what we already know. This is called our prior knowledge. Then we'll get into the lesson. And throughout the lesson, I'll be checking for your understanding. Now let's talk about the basics. Did you know algebra didn't start in middle school? You've been doing it since elementary school. We just upgraded the symbols. In elementary school, you saw problems like blank plus 4 equals 10. Your job was to find the missing number, the value that made the equation true. You might have said 6 plus 4 equals 10, or you might have subtracted and said 10 minus 4 equals 6. That blank was doing the same job as a variable does now. The only difference is that instead of a box or a blank, we're now using letters called variables. And just like in elementary school, you had to use the inverse operations. That means the opposite operations. So what's the point of solving equations? Solving an equation means finding the value of the variable or the blank that makes the equation true. If the value makes both sides equal, then the solution is correct. An equation is like a balanced scale. If both sides aren't equal, that means that the math is wrong. For example, 6 plus 4 equals 5 plus 5. Both sides equal 10, so the scale is balanced. When we solve equations, our goal is to keep both sides balanced while we find the value of the variable. Now let's go over the steps to solve any equation. Step 1, identify the variable. What letter are we working with? This is the value we are solving for, so keep your eyes on it the entire time. Step 2, combine like terms using inverse operations. If the terms are on the same side of the equal sign, combine them like normal. But if the terms need to move to the other side of the equal sign, you must use the inverse operation. Now I'm going to repeat myself because this is where most people go wrong. Take note. If like terms are on the same side of the equal sign, so if they're all on the left side of the equal sign, you can combine them like normal. Watch our combining like terms that we have here on Mathora. But if a term needs to move to the other side of the equal sign, so if it needs to go from the left side to the right side, you must use the inverse operation. This is how we start isolating the variable. And that brings us to step 3, isolate the variable. That means get the variable to one side of the equation by itself. Step 4, solve for the variable. Once the variable is isolated, perform the final operation. Last but not least, step 5, check your work. Substitute your solution back into the original equation. At the end, you're going to get x equals, a equals, y equals. Take that number, put it back into the original equation, and if both sides are equal, aka if your scale is balanced, your answer is correct. Checking your work will always tell you if you're right or wrong. There is no reason to skip this step. You have to take responsibility to check your work. So here's a quick summary. Identify the variable. Combine like terms using inverse operations. Isolate the variable. Solve for the variable, and check your work. Let's get started. Let's get started with example 1. Example 1. Here we have m minus 28 equals 54. Our variable is m, and now we need to combine like terms of the 28 and the 54. Since it's going on the other side of the equal sign, we must do the opposite of subtraction, which is addition. So we're going to add 28 to both sides. And the reason why we do the inverse operation is because it's going to cancel out. Negative 28 plus 28 is 0, so we just cancel it out. Now on the left-hand side, we are still left with m. So m can come down, Now let's finish solving the equation. 54 plus 28 is going to equal 82. Now we're done solving the equation, but let's check our work to make sure that m actually equals 82. So I'm going to rewrite the original equation since I kind of crossed it out on the left-hand side. So the question is, what is m? Well, we just found m, and m is going to be 82. So we're going to plug in 82 for m. So the equation really says 82 minus 28. And this does equal 54. So therefore, we know that m is 82. We know that we're correct, so we can box in our final answer. Example 2. Here we have 6p equals 96. On the left-hand side, this says 6 times p. And we want p to be alone, so we have to do the inverse of multiplication, which is division, which means that we have to divide both sides by 6. 6 divided by 6 is 1, so we just cross it out, and that leaves us with p. So p equals 96 divided by 6, and that's going to be 16. So here we have p equals 16. Now let's check our work to see if that's really true. Remember, 6p is read as 6 times p, so when we're checking our work, we need to do 6 times 16. And 6 times 16 does equal 96. So therefore, we know that we are correct, and we can go ahead and box in our final answer. Example 3, a two-step equation. Here we have x plus 5 minus 7 equals 23. Now, before we move one term at a time, we can actually combine like terms on the left-hand side, then move it over to the right-hand side. So remember, when we're combining like terms on the same side, we combine them like normal. So this gives us x minus 2 equals 23. Where am I getting minus 2? Well, positive 5 minus 7 is going to be a negative 2. Now we can move the 2 to the other side of the equal sign by doing the inverse operation. So we need to add 2 to both sides. Negative 2 plus 2 cancels out, and that leaves us with x. And x equals 25, because 23 plus 2 is 25. Now let's see if this is true. X plus 5 minus 7 equals 23. I'm going to replace x with 25. So we have 25 plus 5 minus 7 equals 23. 25 plus 5 is 30. 30 minus 7 is 23. So therefore, I know that my answer is correct, so I can go ahead and box it in. X equals 25. So here's our first check for understanding. Fill in the blank with a description of the first step. Go ahead and pause and try it out. 5y minus 12 equals 68. Yes, the very first step is to add 12 to both sides, then divide both sides by 5 to get 16. Example 4, multi-step with parentheses. We have negative 4 times the quantity of t minus 8 equals 64. The first thing we need to do is distributive property. We're going to distribute the negative 4 to each term inside of the parentheses. So negative 4 times t is going to give us negative 4t and plus 32. I get a positive 32 from multiplying negative 4 times a negative 8, and that gave us a positive 32. And equal it to 64. Now we need to combine like terms by moving the 32 to the other side of the equal sign. So we need to subtract 32 from both sides. 32 minus 32 cancels out. That leaves us with negative 4t on the left-hand side, and 64 minus 32 is 32. Now we need to divide negative 4 from both sides because it was multiplied to the t, and we want t to be alone. Negative 4 divided by negative 4 is 1, so we just cancel it out, and t equals negative 8. Because a positive 32 divided by a negative 4 is going to be a negative 8. Now let's check our work. Negative 4 times, I'm going to plug in for t, which is negative 8, minus 8 equals 64. Now what I'm going to do this as if you are not using a calculator. Okay, so I'm going to use the distributive property. So we have negative 4 times negative 8 is going to be 32. And then once again, negative 4 times the other negative 8 is also going to be positive 32. So 32 plus 32 equals 64. Another way you could have done this is solve what's inside the parentheses, which would have given you negative 16, and negative 16 times a negative 4 would have still given you a positive 64. So our answer is t equals negative 8. Example 5, assessment style. This one is going to be kind of lengthy. 6x minus 3 times the quantity of x minus 10 equals 72. The first thing we need to do is simplify the left-hand side because it's a lot going on over there. So we see that we have some parentheses, and according to Pemdas, we need to solve for those parentheses before we start moving things to the other side. 6x is a standalone term, so we're going to leave 6x as 6x. I'm going to color code negative 3 so you see that's what we're multiplying by. So we're going to distribute negative 3 to everything inside of the parentheses. Negative 3 times x is going to be negative 3x. And then negative 3 times a negative 10 is going to be a positive 30. And then we're going to equal it to 72. One step at a time, okay? Now we need to combine like terms on the same side, which means combine like normal. So 6x minus 3x is going to be 3x. We're going to leave the plus 30 equals 72 because we want to move numbers at one step at a time. Now we need to move 30 to the other side of the equal sign. So the only way we can do that is through the inverse. Subtract 30 from both sides. That leaves us with 3x equals 72 minus 30 is 42. Now we need to divide 3 by both sides because it was still attached to the x through multiplication. 3 divided by 3 just leaves us with x, and 42 divided by 3 is 14. Now we need to plug x back into the original equation. And notice there are 2 x's in the original equation, so we need to plug them both in for 14. So I'm going to go ahead and plug things in. So this says 6 times 14. I should have used a dot for multiplication because that looks like 6x 14, but it's not. That's exactly why we use a dot now. Minus 3 times 14, because I plug in x, 14 for x, minus 10 equals 72. Now, let's do the first multiplication first. 6 times 14 is going to give you 84. Now, we can either use the distributive property or you can go ahead and solve what's inside the parentheses. So that's going to give you negative 3 times 4, because 14 minus 10 is 4, equals 72. So I'm going to rewrite again. 84 minus 12, because negative 3 times 4 is negative 12, equals 72. And that is correct. So therefore, I know that my final answer is x equals 14. I can box it in. All right, this is it. Our final check for understanding. I would like for you to spot the mistake, explain the mistake, and fix the mistake by redoing the work. Go ahead and pause and try it out. Here is an example explanation, and here's how you fix the mistake. If you would like more practice on solving equations, please check out my YouTube shorts or my TikTok. That concludes our lesson on solving equations. If this lesson helped you, like this video and subscribe for more math made clear. Bye, scholars!